So let's start with the goal number one, why a network? Basically, we need to understand the mining challenges and needs that can be met with an NLT digital network. Think of it this way. I had a conversation with two of your colleagues a few weeks ago, and one of them was saying, you know, we were in a tunneling environment, and I never thought about, you know, could they use a network? If there's a hole in the ground and there's people going in that hole, let's say they need a network. And here's the things that they could do with that network. So first of all, basic communication. Mining has been around for a long time, and communication has always been an issue. For quite a long time now, they've had a basic phone system. Most mines will have just these awful little phones, and they're basically a hotline. You pick up the phone and it will ring an office upstairs. That's basically what it'll do. Or if they pick up the phone upstairs, it'll ring all the phones in the mine. It's very basic, nothing much happens there. But if nothing else, you can at least get some health and safety security, or basically say, hey, can you send some equipment down, or can you send some concrete down, or whatever the case may be. That was very limited. They still are required in many cases. And so over the last 30, 40 years, you've seen radios go underground. These are walkie-talkies, just like police, fire, ambulance, or construction workers may use above ground, VHF and UHF radios, but they're limited. And underground, to make them work, you have to have a system called leaky feeder to make them work, because you can't propagate their signal underground. Their waves are too big. And so, again, these are the basic systems that miners have used in the past, and they still use them, but they're very limited. You can't do much with them. You certainly have no data capabilities. And the reality is, these days, there's a lot of data in this world. I mean, we're all carrying these. Most of the miners will have one of these underground, and they can't use them. So why don't we give them an opportunity to do that? Well, if you have a network from us, we can now provide better communication. We can provide phones that can, in fact, be part of their dial plan within the company. You can pick up a phone underground, dial 4 digits, and get the president of the company. How about the supervisor that goes down with a tablet? And there are tablets that are very hardened that are used by miners, and they can bring them underground and they can take pictures, they can do reports, but without a network, they have to go back upstairs to finish their work. Why not give them the opportunity to finish their work underground? If you have a network, that's easily done. Video and other voice communication systems can be added to this. This little guy here is actually a radio that we sell. It's a Wi-Fi radio. It's like a walkie-talkie, but it needs a Wi-Fi network. Well, if you put a network underground, this now combines your voice, your data, and your video all into one nice, tight little package. Tracking is a very, very important requirement for mining. You got miles and miles of tunnels, and you got a bunch of people in different places. Where are they? What about your vehicles? What about assets? Things like pumps and generators and other portable equipment that may go underground and may be left in a specific location, and then somebody forgets to bring it back up. Where is that piece of equipment? Tracking can be used for productivity improvement as well as safety. Lives can be saved, lives can be protected by being able to track people underground. But in order to do that, you need a network. And again, this is both for productivity and safety purposes. Interestingly enough, one thing that happens, especially in environments where you have a union. Often, when the whistle blows, when the 5 o'clock comes or whatever their quitting time is, a driver may actually leave his vehicle on level 3 in some parking spot and then just walk away from it. And then he may or may not tell the next guy who's coming down where that vehicle is. The next shift, the supervisor is running around in a pickup truck with the driver of that vehicle trying to find that vehicle. If you can track it, it's 15 minutes and he's there. So again, lots of things that can be done with a network when you have it in place. Environmental monitoring and response to that monitoring. So mines can be gassy or not gassy, but no matter what, they can also introduce gases. When you have vehicles underground and they're all producing exhaust from their diesel engines, you got CO, CO2, and nitrous compounds that are filling the air. There are gas monitoring systems available. Usually these are standalone systems that will issue an alarm or will just simply track the data, track the information. But On their own, they're not of any value. You have to send somebody down and read them and record them, and they bring the values back up and then track them over time. Wouldn't it be great if you could just simply plug them into a network and capture that information in real time? You can capture information about the health of that equipment in real time. So if it's starting to fail, or if it's starting to miss data, you can then send somebody down and deal with it rather than waiting till the next day to deal with it. Other conditions like airflow. Miners are always putting air down underground, of course, to clear out all these gases. You may want to know how much air is being pumped through the mine. Airflow is a very expensive proposition because those fans use a lot of electricity. If you can monitor that information, you can monitor that airflow, you can then set it for a more efficient flow rate based on the conditions that are present. That reduces costs, it increases productivity. So again, all this information can be brought to the surface and then you can deal with it strategically. What about response to that? What about emergency situations? A gas level goes up very high. Could we then deal with that by turning something on automatically? We can do that. If you bring that information above ground, you can then initiate activity such as turning on a fan higher, or dealing with a pump, or maybe clearing the mine if in case there's an emergency situation. These things can be automated, but it can be only automated if you can get that information above ground. And finally, this is the big area that's happening right now: automation, the Internet of Things, telematics, and remote control. The big risk to mining is always the people. There's health and safety. It also is the limiting factor to a lot of productivity. Mines are now adding a lot of automated equipment underground, and this includes vehicles. This includes these 40-ton haul trucks that are operating autonomously underground. You know, I mean, we think of something like a Tesla running around the city with automated software. These very big, very dangerous vehicles are operating underground on their own, but they still need a network. At the very least, telematics is often a very important piece of information. Telematics is the data that a vehicle captures about itself. This could be things like engine performance, heat, oil pressure, water temperature and pressure, exhaust. It could be how a vehicle is being operated. Is it being accelerated, or is it braking too quickly? In other words, is the driver not operating in a safe mode? All this information can be captured, and typically it has to be downloaded when it gets to some sort of a station. What if that vehicle was able to simply download or upload that information on a regular basis as it's traveling through the mine? Again, the network is what allows that to happen. And there's a whole list of things that can be automated, and these things are happening today. And this is where we actually have some experience. We have some mines that are starting to do these very things. I have a Lac-des-Îles up in Thunder Bay is going deeper and deeper, and in the interest of limiting how much ventilation it's putting down in those deep parts of the mine, it's using automated vehicles instead, and it's using our network to make that happen. All right, so let's understand the solution itself. So as I said earlier, there's two components. There's N-Connex and there's Digital Mine. N-Connex is the network itself, basically the thing that will move the data. Digital Mine is a software suite that will capture that data and allow you to do things with it. Oops, sorry. So N-Connex itself was designed around being specifically used for tunnels and mines. Okay, so what is N-Connex? N-Connex are digital switches, just not unlike the switches that are used in the carpeted environment. In other words, think of Cisco, think of Juniper, think of all the big names in the networking industry. This is really nothing different. It's just form factored and made small for the application. You can take any piece of expensive equipment and bring it underground, but it's going to be a lot more expensive to put it into a safe cabinet that will protect it from the water, from the dust, from the dirt, from the electrical noise that's in the area. This stuff is designed to go specifically for that environment. User-friendly rail-based mounting systems. Number two, when we mean user-friendly, why is that? The people that are going to be using this stuff are just miners. These are hardworking folks. They're practical, they're electricians. They're not. It's designed to be used by people who really don't understand networks. It's modular, plug and play for easy maintenance, rapid deployment, redeployment, and expansion. The whole idea behind this is if you take an expensive switch that goes above ground and try to put it underground, it's not going to be easy to move. It's not going to be easy to expand on it. It's not going to be easy to maintain it. This stuff is designed for all those things. You can see that in this picture, this is an actual live environment. This was actually in a tunnel in Austria that I helped build. These products are designed for a nasty environment. They're designed to be put up very quickly, and they're designed to be plugged in and plugged into the network with ease. And yes, all networks are modular, but these are modular with the understanding that the people who are putting them in there, putting them underground, are not people who understand networks. IP67, what is that? That is intrusion protection. It is basically a level of a standard that indicates how much stuff can get inside these boxes. IP6, the 6 stands for the fact that this thing is dust tight. Dust will not get inside these. The 7 means that you can actually put these underwater for about half an hour or an hour, I forget which, and they'll still work. So basically this is for what is a dusty, dirty, dangerous, and wet environment. And finally, the power supplies that are associated with this equipment are designed so that when you plug 120 volts into the system then powers everything else from it. So you don't have to bring 120 volts to every piece of equipment that is out there. This is called PoE, or Power over Ethernet. And this is something you will see, and something that I'm going to ask you to get slightly comfortable with. Basically, that Ethernet cable that you plug in the back of a computer can also provide power. And that power is what's used to power cameras, access points, or even other communications devices like this phone or this alarm module. These are actually powered from the switch over this low power voltage coming from the data cable. Just a closer picture of the form factor of these devices. Basically, this is an extruded aluminum enclosure that's sized to fit the particular application. These are high impact plastic end caps that seal everything up with a gasket. All of the colors are meant to be very bright, so these are easily viewed from the distance. The LEDs are very bright on these, so again, in the darkness, you can see this thing from far away. All the connections are underneath, so even if there's water pouring on top of this thing, you're at least protecting the connections as much as possible so they stay dry, especially during maintenance when you're maybe disconnecting and reconnecting something, so you don't wind up getting water or dirt into these connectors. Just to let you know, these are fiber connectors and these are data connections. These are actually Ethernet connectors, just like you would have on the back of your computer or a switch on a Cisco switch. So here's the main component. This is the distribution module kit. This is where everything begins. The distribution module kit is the switch itself. Again, doesn't look like anything you've seen before, but this is nothing more than a switch, just like in any office. It's just a form factor for the mining environment. This is the wall wart. This is the power supply. You plug this into 120, and then it provides the power to the switch. And finally, there's a backup battery. Between the three of them, these things can basically operate without power for somewhere between 8 and 12 hours. We guarantee 8. The 12 is not likely. It all depends on what kind of stuff is connected to it, how much data they're moving. But this is the family photo. This is the main component. Now, as I said before, one of the things that makes this easy is the form factor and how easy it is to deploy. We basically tell a guy who knows how to drill a hole in a wall and put a bolt in it, here, drill 2 holes, drill one here, hang these 2 brackets, hang the rail, this black rail you see on the back of this, on these 2 brackets, and then just hang these boxes on it. Bingo, bango, bongo, you're done. This is a 15-minute job. Connect the cables and start running them in all directions as necessary. That's all it is. And that's what makes it just absolutely brilliant. You can, typically you'll send an electrician out with, or maybe with one guy helping them, and they'll put it up in 15 minutes. The electrician then provides power to this, and you're up and running. You then bring fiber cable to this guy from the surface, and you now have your first data network point, your first data network switch underground. And then from there, you just go on from there. So let's put it all together. This is, if you understand this picture, and I know there's a lot of things in here, but basically, this is the kit. This is the distribution module, power and battery that you put in the mine. You run fiber to it from the surface, and then you run fiber from it to the next access, to the next switch, and then hang access points from this switch. You've now created an environment where you have somewhere between 800 and 900 meters of Wi-Fi coverage in a tunnel. Now, depending on the circumstances, these can be closer together or they can be further apart. This is a typical building block. Consider it to be like Lego. When you're dealing with all these miles and miles of tunnel, you basically bring the fiber down, connected it to the switch, bring the fiber out and go to the next switch. And along that tunnel, you lay out some Wi-Fi. And this is what happens here. And this is nothing more than one of these building blocks. Sorry. Getting a little dry here. Now, if you have any networking experience, you'll notice that this is just a single line of switches. And this represents a very basic network. The nice thing is we can branch off. We can actually, from one of these switches, we can go off in different directions. So we can actually create like a tree diagram out of this. And yes, we can actually loop this back and connect them together, forming a redundant network. So that if something breaks, because as a colleague of mine said, in mining, everything breaks all the time. If you were to lose a cable, if you were to lose a switch, all of a sudden you would have a broken network. But if you have a redundant loop, redundant path back out of there, okay, it's just a minor inconvenience. We'll send somebody down and repair that piece of equipment, or we'll repair that cable, and we're back up in business. So I just wanted to point out that this is just a very simple network diagram. But I'll in the future, when I send out certain email blasts, I might show you some examples of networks that are a little more sophisticated than this. But again, if you understand this basic concept of a switch, a bunch of access points, and then build it from here, you've got the basic idea of what a network's all about. All right, so we're done with the hardware. That was the N-Connex portion. Now is the software part. So Digital Mine is the software suite we developed to basically add a lot of applications to the network. I mean, a network is one thing, but you got to do something with it. So yeah, great. You got a cool, shiny new network. What can you do with it? Well, this is where we start. I mentioned earlier location tracking. This is one of our biggest sellers. Just being able to find people underground and equipment and vehicles. This is key. This is one of the most beautiful parts of this particular solution. Environmental monitoring. We can capture information from monitoring stations. And this could be things like gases. It could be extensiometers, which basically tell you whether or not your ground is moving under your miners' feet. That can be captured. We can capture airflow information. We can capture other environmental monitoring like temperature, wet bulb, pressure, etc. These things can all be captured and reported, stored and reported on through this environmental monitoring application. And as I said, there's real-time reporting. The idea is that you can create graphs from some of these things that operate on a regular basis. So the environmental monitoring will have a graph. If you have a very important station you want to keep track of, let's say nitrous oxide compounds, you can keep a graph on your screen showing that, how that's building up or going down. And in emergency management, based on an automation, based on the data that's available in Digital Mine, you can automate activities. You can say, oh, I'm seeing too many people in a location and I'm seeing the gases are going up. What am I going to do about that? Well, automation can say, great, let's spin up that fan faster so you're moving more air through that location. Emergency management can also say, I've got dangerous levels of CO. Let's evacuate people. I can, based on a threshold of X, I can now issue a command to all those alarm systems saying, please get everybody out of the mine, or get them into refuge, or get them on their supplemental oxygen, whatever the case may be. So these are all the various things that we can do with Digital Mine, and there's more being developed all the time.